both hands?
Yes, yes. Come again.
Sir, when you row a boat with both hands?
When you row boat with both hands. Okay, okay, yes, yes, yes. Any more practical example? Any?
Sir, can you please repeat the examples of a class 2 level?
Sure, sure. I will revise all three. This time I'm doing. Yes. But first, let me check whether you revise or not. Lever is an example of simple machine. There are three classes of lever. First, in which fulcrum lies in
between effort and load.
effort and load. Lever of type 1. Shrey, example of first type of lever. Shrey, example of type 1 lever.
Seesaw.
Seesaw. Or at least 4 examples. Seesaw. Kabir, example of type 1 lever. Kabir. Kabir. Oh.
Sir, may I answer?
एक second. Mic is not working. Okay. किसने hand raise किया? Vihan, Shrey, Tejasvi. Very good. Okay. Tejasvi, give me 3 more examples of type 1 lever.
So scissors, water pump, and
Pair of scissors and hand pump. Okay. One more.
Claw
One more.
hammer.
One. Uh-huh.
Claw hammer.
Claw hammer. Okay. Simple plier. Any plier that
Sir, a simple weighing machine.
weighing machine. Weighing balance. In fact, machine is little weighing balance. जिससे हम सब्जी खरीदते हैं. Right. Class 1 lever, type 1 lever. Any pliers? Right. विक्रमादित्य, type 2 lever क्या होता है बीच में? Type 2. विक्रमादित्य,
Yes, sir.
what lies in between in type 2 lever? Class 2 or type 2?
8 seconds, sir. It slipped out of my mind.
My voice is not clear. Come again. What lies in between? Effort or load?
Load lies in between.
Load lies in between. Right. Okay. Load lies in between one side fulcrum and effort. Example of type 2 lever, Riddhi.
sir, a nutcracker.
A nutcracker. Okay, right. And
A bottle opener.
nutcracker, bottle opener. But if you open bottle with the spoon, then it will not be. Then it will be which class?
Class 1 lever.
Class 1 lever. Okay. And
Sir, when we use a bar to lift load.
yeah, bar to lift the load. Tejasvi, one more.
Sir, wheelbarrow.
Wheelbarrow.
Sir, lemon crusher.
Lemon crusher. Fine. Okay. Type 3. Type 3, Mr. Vihan. अभी वैसे पूछा था मैंने. Come again. What is the type 3 lever? Class 1, type 1 is the same thing. Obviously, the fulcrum will be one side, effort lies in between load and fulcrum.
Yes, sir.
Examples.
The sugar tongs and the
Sugar
speed
tone.
lifting a load. And one I said when you row both with both hands.
Correct, yes. And
A
knife,
knife, yes, knife also.
and
And a,
uh-huh.
and a foot reader like that.
Okay. Spade, lifting a load. There are two types of, two uses of a spade. Spade where it is used to dig the earth, then it is
So, sir, I didn't hear what you said. Can you repeat?
okay. Spade, when it is spade is used to lift the load, and when a spade is used to dig the earth or soil. So when it is used to lift the load, then you take the effort, we hold it from the center with the one hand, and that's why it is going above the, I mean, effort lies in between, right? Fine. Okay, so next is we have to see the working of all. I think we did see the working of these working principle kya tha? What is the principle of working of this machines, Mr. Okay, Mr. Jayesh, working principle of lever.
Uh, sir, working principle of levers समझ नहीं आया.
Principle of
What did you
movement.
mean the question?
Question is, how does a simple machine work? What was the principle which was written in the name of principle of moments or principle of lever? Principle of lever. Check your notes. We did this topic. We didn't revise, I guess. Principle of lever, Tejasvi.
So it is the work output is equal to work input.
Yes, work output is equal to work input for an ideal.
Sir, you asked about lever. मैंने ये ideal
Yes,
machine के
sir.
अंदर रखा हुआ है.
हाँ बेटा.
सर
मैंने
आपने
ये
principle
exact
of
चीज
levers
लिखी हुई
पूछा.
है. आपने principle of levers पूछा. I have written this under what is an ideal machine.
तो principle of machine नहीं है तो.
No, that is principle of machine. But principle of lever is also
Same.
okay. Okay, understood your point. You got confused between the lever and machine. So that is the principle of ideal machine. So this is what you gave as an answer is principle of ideal machine, that the output work is equal to input work. But usually this is not possible. There will be some energy losses due to friction and all, and therefore the efficiency cannot be 100%. If efficiency is eta percent, then output work or output power is eta by 100 times input power, right? In the work input, sorry, work done per unit time, so same will be the power output. Output power will be eta by 100 times input power given. Work done per unit time is power, so the same relation will be for the power also. This is input power, right? Efficiency cannot be 100%. Why? What is the reason?
Sir, because the moving parts are not perfectly smooth and the string or the wire is not perfectly elastic, and plus the moving masses like the pulleys are has some weight, so we have to apply extra force.
Okay. So there are 2, 3 reasons friction is not upset, and the parts of the machine used is not weightless. They have some weight of its own, which also has to be overcome. Mechanical advantage formula, Riddhi. Mechanical advantage.
So mechanical advantage is load upon effort.
Load upon effort. Okay. Mr. Shrey, what is the relation, velocity ratio and the relation between velocity ratio and efficiency? Velocity ratio.
Sir, velocity ratio equals to velocity of effort upon velocity of load.
Okay, but velocity, so फिर हम right उसको कुछ displacement भी convert कर लेते थे, displacement of effort. Now it is a velocity ratio, correct? But velocity तो नहीं, हम displacement is equal to displacement of effort divided by displacement of load. Kabir, your mic got fixed. बेटा mic connect कर लो, ये अच्छा तरीका है बचने का. You can do external mic. Displacement of effort divided by displacement of load. We need to communicate. You cannot go to the chat box again and again. Velocity ratio is velocity of effort divided by velocity of load. What is the relation between efficiency, mechanical advantage, and velocity ratio? Are there relation between the three?
So machine advantage equals velocity ratio into efficiency.
Okay. And this derivation is asked in the board, and hopefully it will happen next year, this year. So it was total wastage. Mechanical advantage is velocity ratio multiplied by efficiency. Mr. Vikramaditya, for a speed multiplier, mechanical advantage is greater than 1 or less than 1?
Greater than 1.
Uh-huh.
So it's less than 1.
Advantage is greater than 1, less than 1, equal to 1. Okay, stay.
Yes,
Speed multiplier, velocity ratio greater than 1, less than 1.
less than 1. नहीं अब मैं force multiplier को greater than 1 and speed multiplier less than 1.
Force multiplier में velocity ratio greater than 1 होता है. Mechanical advantage भी greater than 1 होता है. In the speed multiplier, velocity ratio is less than 1, mechanical advantage is also less than 1. Right? Okay, I think till this point we did, and I asked you to do some examples and numericals. Right, so only one thing was left, that is the principle of lever. Principle of lever. Principle of lever, which is used to calculate the mechanical advantage of the lever. So let's take any example, class 1 or class 2 or any kind of suppose it is a simple machine. One side we apply effort, this side is some load to overcome, and this point is fulcrum. So in this case, fulcrum becomes like the point of axis of rotation about which effort rotates anti-clockwise, load rotates clockwise. This machine will be, this weighing machine or weighing balance will work when their moment cancel out each other. So in this, principle of lever works on the principle of moment. This is class 1, and similarly for all the class lever, it works on the principle of moment, which means when it works on the principle of moment, Principle of moments क्या था? In equilibrium, in rotational equilibrium, the net torque or net moment is always zero. In rotational equilibrium, general word equilibrium because it is in both the type of equilibrium, translational as well as rotational. In equilibrium, the moment of load about fulcrum is equal to moment of effort about fulcrum. Moment of load about fulcrum is equal to moment of the effort about the fulcrum. Right?
Sir, can you please give me a minute? I'm noting this down.
हाँ बेटा
सर 1 मिनट चाहिए हमें सब नोट करने के लिए.
अच्छा ठीक है नोट कर लो समझ में तो आ रहा है ना प्रिंसिपल ऑफ लीवर सॉरी नॉट लेवल प्रिंसिपल ऑफ लीवर so it is obviously that if it is an ideal lever then that will also be here that work output or output power is equal to input power.
सर ये सिर्फ क्लास 1 के लिए या फिर क्लास 2 और क्लास
ये
3
सभी
के
के
लिए भी
लिए
ये
बेटा
सेम है?
सभी के लिए दिस इज फॉर ऑल.
ओके, अगर एफर्ट बीच में होगा तो फिर मूवमेंट ऑफ
all the type of lever right. So moment कैसे कैलकुलेट करते थे हम force into perpendicular distance so any type of lever is there in the class 2 load fulcrum effort this is class 2. Class 3 load is fine. So in any cases अब इसमें क्या होगा जहां पर load है the distance between load to fulcrum that is called load arm. The distance between load to fulcrum is called load arm and the distance between effort to fulcrum is called effort arm.
सर ये तो बिल्कुल उसकी तरह ही हो गया टॉप की तरह. तो एफर्ट का हमारा डिस्टेंस ज्यादा है तो कम फोर्स होगा, राइट?
Correct. ये torque के principle ही पर ही balance है. So EF in all the it is working on the principle of torque only. Right. So in all the cases, the distance between effort and fulcrum will be called effort arm. So EF is effort arm. The distance between load and fulcrum LF will be called load arm. So moment of load must be overcome by the moment of effort applied. So moment के लिए formula होता था force into perpendicular distance. So we can say that load in all these three diagrams, the distance between effort to fulcrum is called effort arm. About fulcrum only it is balanced. The distance between load to F is called load arm. So I'm writing it as L so that you
सर
understand
क्लास
that it is
3 लेवर में तो क्या ग्रेविटेशनल फोर्स भी पार्ट प्ले करेगा?
सभी में प्ले करेगा. ग्रेविटी तो हर जगह होती है ना. ग्रेविटी तो कहाँ जाएगी? In all the three levers, gravity is playing the role. But
सर क्लास 1 लेवर्स में तो एकदम फलक्रम के थ्रू जा रही है तो कैंसिल आउट नहीं हो जाएगा?
force तो लग रहा है ना उसका torque नहीं है but obviously force is acting there so you have to balance that. Gravity force is acting, yes. Okay. So in any case, when we calculate the torque is force into its perpendicular distance. The perpendicular distance of load from the fulcrum is called load arm. This must be equal to the moment of force or torque applied by effort. It is called effort into effort arm. So load L into LF is equal to E into आपकी book में BF और AF लिखा हुआ है for the effort. I use this notation EF to understand that this is the distance between point of application of effort and the fulcrum. So from here we get the relation load and by effort, and it has nothing to do whether it is ideal or not. This has to be always, this has to overcome always. Load to effort ratio is equal to effort to fulcrum divided by load to fulcrum. So load to effort ratio is effort arm to load arm. And the ratio of load to effort is called what? The ratio of load to effort is called? Yes.
Mechanical advantage.
Mechanical advantage. So mechanical advantage of a lever is the ratio of load to effort, or it is the ratio of effort arm to load arm. So load or effort to measure करना directly possible नहीं होगा, but from any diagram, from any lever diagram, we can easily see that whether load arm is bigger or the effort arm is longer. So this relation that load divided by effort is equal to effort arm by load arm and is equal to mechanical advantage. This is called principle of lever. Right? So now we can see in class
Yeah.
1,
सर एक
in
बार
class
मेरे को
1
नोट
lever,
करने दो प्लीज.
effort arm. अच्छा, note करना, ठीक, करो, note. Give me just a minute. Note it down. Yes, done. Noted. Done.
Yes sir. I noticed it.
Okay, now from the diagram we can see the effort arm or load arm, which one is bigger, which one is longer, and accordingly we can decide the mechanical advantage. Mr. Kabir, Kabir, Kabir. बट आपने माई का कुछ करो यार, तुम ऐसे नहीं चलेगा। क्लास 1 लीवर मैकेनिकल एडवांटेज कितना होगा श्रेय? श्रेय,
Greater. Yes, sir.
क्लास 1 लीवर,
Equal.
क्लास 1 लीवर
Greater than 1.
ग्रेटर देन 1, लेस देन 1, और कुछ भी हो सकता है। इट इज इन बिटवीन ना, कहीं भी लगा दो फुलक्रम, बीच का मतलब ये थोड़ी कि एग्जैक्टली मिड पॉइंट पर ही है। आर यू गेटिंग इट?
Yes, sir.
So for class 1 liver, mechanical advantage can have any value. Only and only when both are equal, like the case of balance. So for class 1 liver, mechanical advantage is 1 if effort R is equal to load R. Mechanical advantage can be less than 1. In this particular diagram, it is less than 1. The diagram that I showed here. If effort arm is less than load arm, as the diagram shown. The previous diagram that was, it is exactly equal length, the class 1. Mechanical advantage is greater than 1 if effort arm is greater than load arm. If effort arm is so point इतना था कि in the case of class 1 lever, it can have any value. जैसे यहाँ पर mechanical advantage less than 1. In the third diagram, mechanical advantage is greater than 1. And when it is exactly at the midpoint, mechanical advantage is equal to 1. Right? If mechanical advantage is greater than 1 and it is an ideal machine, for an ideal lever, what will be the velocity ratio, or any type of velocity ratio will also be equal to 1. If mechanical advantage is greater than 1, sorry, less than 1, velocity ratio is less than 1, greater than 1. It will also be less than 1 because their ratio is constant. So class 1 lever can have anything, can have any value. So mechanical advantage, how much we have to gain. Accordingly, we change the size, the length of effort arm and the load arm. If you want more advantage, then the effort arm should be greater. Correct? So in the class 1 lever, it can have any values less than 1, greater than 1, or equal to 1. In all these examples, you can see from your book, there are given. Yeah, just a second. Okay. Yes. Class 2 lever में क्या होगा? Class 2 lever is, yes, Tejasvi, class 2 lever, which one is greater, effort arm or the load arm?
What sir, मुझे आपका question समझ नहीं आया.
In class 2 lever, which one is greater, load arm or the effort arm? This is the load.
So I am not sure. I think effort arm.
Why are you not sure? It's clear in the diagram. E to F length will always be greater than L to F. This point is the load point, and here it is E, effort. In class 2 lever, effort arm is always longer. The effort arm is always longer than the load arm.
Okay.
Right? So what about mechanical advantage then? Greater than 1, less than 1?
So
Okay.
mechanical. Okay.
Yes. Yes, it is greater than 1, less than 1.
So greater than 1.
Greater than. अच्छा, आप लोगों की मैथ की कॉपी चेक होके मिल गई ना शायद? You got your marks?
सर नहीं मिले।
नहीं मिले सर।
अच्छा, वो हाँ सही. Okay, I remembered what happened. The marks are so wonderful, so extremely well performed. I will give it to the parents in the PTM. Don't know what was the reason, but
Sir,
not even
which
a
one?
single
In the last one?
first test, not the physics. I'm talking about the maths one, the test that
Sir, quadratic equations वाला ना?
जो अभिजीत सर ने दिया था कुछ रात में.
सर
Yes.
उस वाले में we didn't know a lot of the questions क्योंकि हमने word problems करे ही नहीं थे quadratic equations के. Only
बेटा
the
ये सब अंग्रेजी में नहीं समझता हूँ, ठीक है. And if you
सर
are
हमने
attempting a
सिर्फ
paper,
पहले 5 क्वेश्चंस हमने कवर किए थे, उसके बाद के हमने करे ही नहीं थे. वो वर्ड प्रॉब्लम से जो हमने किए ही नहीं थे सर.
यस सर, हमने चैप्टर 6 अभी करा ही नहीं था और उसके क्वेश्चंस आ गए थे। स्टार्ट भी नहीं करा था हमने
अपने
चैप्टर।
पेरेंट्स को समझाना. या मतलब अभिजीत सर से भी पूछ लूंगा because मैंने उनसे बात नहीं हुई, but your marks none of you could cross 2 digit.
सर आई हाईली डाउट अटेम्प्ट भी किया होगा किसी ने 2 डिजिट का क्योंकि वी डिडंट नो हाउ टू डू इट, वी डिडंट कवर दैट सिलेबस. हमने सिलेबस नहीं किया था वो वाला.
सिर्फ फर्स्ट 5 क्वेश्चन से करे थे सर।
तो टेस्ट को फिर ऐसा क्यों हुआ कि आपको वो टॉपिक नहीं पता है, या वो those topics are
सर
not in your
वही तो।
syllabus?
सॉरी सर।
All those topics that you didn't attempt, are they not in your syllabus?
सर
सर
हमने
ये
तब
यार
किए नहीं थे.
अच्छा,
सर
तुम
ये
लोग
आ
रुको.
रहे
रिद्धि you please tell because इन पे तो भरोसा नहीं. रिद्धि,
Yes, sir.
what happened in the first test of
So
maths?
in the quadratic equations test, the word problems, we hadn't done it. We just completed it last class. So
पेपर
those
तो शायद
questions.
अभिजीत सर ने ही बनाया था. It was not from our side. या अभिजीत sir himself gave the questions. Okay, चलो मैं उनसे पूछ लेता हूँ because yes, copy was checked and it was given to me because it was so wonderful and so disastrous. 4 marks, 5
और
marks, something like
सर
that.
क्वाड्रेटिक इक्वेशंस के पहले हमारा एक और टेस्ट हुआ था, वो भी हमें नहीं मिला है, लिनियर इनइक्वेशंस का.
अच्छा, ठीक है. नहीं, अभिजीत सर के तो ठीक है, मैं उनसे एक बार बात करता हूँ. But yes, I want to give the copy now in hand in the PTM or at least virtual PTM, online PTM, whatever. And we'll explain each and everything. You can explain each and everything in that PTM. To me also and to Abhi sir also and to parents also. Yeah, I mean, it should not be just for fun, the test. You have to take it little seriously.
सर वी डिड टेक इट सीरियसली. हमारे सिलेबस हमने किया ही नहीं था सर.
उस दिन बोलना चाहिए था ना, आप कॉपी चेक होके मार्क्स आ रही है तब बता रहे हो कि ये ऐसा
सर
है
हमने
सर
उस दिन
हमने
बोला था।
मैम को बोला था, उन्होंने कहा था कि जितना अटेम्प्ट हो रहा है उतना कर लो।
चलो ठीक है, फिर सर से बात होगी, उसके बाद बात करेंगे। चलो लीव इट, कम बैक। Class 2 lever, mechanical advantage is effort arm over load arm. Effort arm is always greater, so mechanical advantage is always going to be greater than 1. Velocity ratio is also going to be greater than 1. Velocity ratio का तो ये formula ही था, effort displacement of effort divided by displacement of load. Displacement of effort can be maximum equal to the effort arm. This is the velocity ratio, right? So if it is more than 1, velocity ratio, can it be used as speed multiplier? Can it be used as a speed multiplier, Adya? Class 2 lever always act as force multiplier. Velocity का greater than 1 है तो speed कम हो जाती है. Always act as force multiplier. Cannot be used as the speed multiplier. Yes, class 2 will always, so that means with a small effort you can do a bigger things and larger things. Like with a small effort you can crack a very hard nut, you can open a bottle, and with the help of wheelbarrow, right? Okay, this is the class 2 lever example. Class 2 lever will always have mechanical advantage greater than 1, velocity ratio greater than 1. Velocity ratio greater than 1 है, so as it cannot be used as speed multiplier, or but it will always act as force multiplier. उसमें भी हम लोड की आर्म को, लोड की आर्म को छोटा कर देंगे, एफर्ट आर्म को इंक्रीज करते जाएंगे, एंड more will be the mechanical advantage gained from this lever. Next is class 3 lever. Next is class 3 lever. For class 3 lever, Kabir, class 3 lever में क्या था? Effort is in between always. Effort is always in between, so correct. Effort arm is always smaller than the load arm. In class 3 lever, effort arm is always smaller, shorter rather, than load arm. So what will be its mechanical advantage? Yes, what will be mechanical advantage in this case?
Sir, it will
Always
be
less
less
than
than
1.
1.
Effort arm to load arm, and it will always be less than 1. So for class 3 lever, mechanical advantage is less than 1. So if we have to do the bigger task, if we have the bigger load to overcome, then class 3 lever is not suitable. Right? Velocity ratio is less than 1. Velocity ratio is less than 1. Okay. Their values are not necessarily equal. Velocity ratio and mechanical advantage. This is equal only for right. In actual lever of class 3, so we can use that mechanical advantage and velocity ratio to calculate efficiency. The value will depend upon the efficiency of that cycle. It will not be same. If 100%, only then they both are same, but it is always less than 1. And if velocity ratio is less than 1, then it gives this gain in speed. So it is used as it can be used as a speed multiplier, not as a force multiplier. It can be used as speed multiplier only. Not as a force multiplier. What does this mean if we use a small movement of the effort? We get more gain in the speed. So displacement of load is larger than the smaller displacement of effort. Load displaces more than the effort. Load displacement is more than the displacement of effort. Okay, right? Velocity ratio less than 1, that means speed multiplier, and for mechanical advantage greater than 1, that means it is force multiplier. Now in this case, class 3 lever or any, the efficiency can be calculated by mechanical advantage divided by velocity ratio, or velocity ratio will be mechanical advantage divided by efficiency. That's how we can interconvert to each other. Okay. Example of each class of lever is found in the human body. All the 3 types of lever. Class of levers found in the human body. Okay, so what are the type of levers present in the human body? Muscle movement, bone movement, all 3. So in human body, all 3 type of levers are found. By using the muscular forces, we apply effort, and in the movement of the body, we get output as a load.
सर क्या एल्बो जॉइंट एक क्लास 1 लेवर की तरह काम करता है?
आते हैं, not the elbow joint. All the 3 classes of lever all the 3 classes of levers are found in the human body. Nodding your head is class 1 lever. Right? Example of class 1 lever is the nodding of your head.
सर नॉडिंग ऑफ हेड क्लास 1 लेवर कैसे? लोड क्या है?
Okay. Right. I'm not very good at trying. So what I will do is I'll show this on the screen only. No, I'm good at drawing, but I don't want to waste time. Yeah. Just wait. Is this diagram visible? Is this diagram visible on your screen?
Yes, sir.
Yes.
Right. So in the case of first class of lever, it is the movement or nodding of your head. All these class PDF are also being uploaded to the group, right? In your app, Biceps team app. Very nice. Yes, that's the advantage of online class. बेटा समझ आ गया
Sir, this
मिस्टर
is being
विहान? मैं समझ
uploaded.
This is being
All of these
uploaded.
notes.
Yes. All these notes. So you can see, Vihan, this is fulcrum.
Yes, sir.
Muscular forces exert the force, and there is some resistance. You are trying to speak or you are trying to bend your head, something like that. So that's the opposite to that is a resistance. So class 1 lever is seen in the nodding of the head.
सर रेजिस्टेंस फोर्स समझ नहीं आया, मसल अप्लाई करती है फोर्स की तरफ हम फल्क्रम वगैरह।
एफर्ट लगा रही है क्योंकि इसकी वजह से तो आपके नेक जब आप नीचे कर रहे हो अपना हेड करके देखो तो आपको जो स्ट्रेचिंग फील होगी वो यहाँ पे होगी। दिस इज द एफर्ट,
हाँ पीछे को फील हो रही है।
राइट। अब जो आपका हेड है नॉट करना मतलब क्या है? यू वांट योर हेड टू गो डाउन, राइट? और मे बी यू गो अप आल्सो, दैट्स लोड।
बट सर रेजिस्टिव फोर्स अगर रेजिस्ट कर रहा है तो उसको उल्टी डायरेक्शन में नहीं होना चाहिए अप्लाइड फोर्स पे।
क्या फिर से बोला?
सर अगर रेजिस्टिव फोर्स है तो उसे अप्लाइड फोर्स को उल्टी डायरेक्शन में नहीं होना चाहिए।
नहीं, रेजिस्टेंस का मतलब वो फ्रिक्शन वाला नहीं है। रेजिस्टेंस का मतलब वो लोड ही है, उस लोड का दूसरा नाम लिखा हुआ है। लोड इज कॉल्ड रेजिस्टेंस इन अ वे बिकॉज़ इट हैज टू ओवरकम।
ओके सर।
तो लोड ये है कि अगर आपका ये यहाँ पे फल्क्रम नहीं लगा होता तो आपका जो पूरा हेड है वो होल that will fall down. So basically there is some resistive force that you need to apply by the muscular forces ऊपर ले जाने में, और नीचे ले जाने में तो नीचे गिर जाएगा इसलिए उसको हमें ऊपर रोकना है। So there is some forces required and that force is applied by these muscles, and about the fulcrum. Correct? Okay, spine acts as fulcrum, the point where it is joined. Spine acts as fulcrum, load is the front part and effort is the rear part. Should I write it or it's clear to the diagram?
Sir, please write it क्योंकि ये डायग्राम हम बना नहीं सकते नोटबुक्स में।
बुक में है, बना सकते हैं यार, हम लोगों की तो आर्ट्स अच्छी है, मतलब ठीक है। When I was in school, my art was very good, but
सर
spine
बना तो सकते बट टाइम ज्यादा लग जाएगा।
हाँ तो मैं शॉर्ट फॉर्म में लिखता हूँ। Spine is fulcrum. Spine is fulcrum, right? Load is the front part of the head or which we are moving or which we are using to speak. And effort is the muscular forces. Effort is by the muscular forces at the back of the head. That's how class 1 lever is found in the nodding of head. Second, class 2 lever. Class 2 lever कहाँ होता है? Yes, example of class 2 lever, Tejasvi, can you think of? Class 2 lever में क्या होता था बीच में? Load. Class 2 lever. Yes, where is the class 2 lever? Right. Is it class 2 lever? No, this is not class 2 lever. This is class 1 lever, I think. This is class 2 lever. Correct. क्लास 2 लीवर जहाँ पे पिवट है, पिवट का मतलब फलक्रम, अगर हम अपना वेट अपने फीट पे उठाते हैं, then that is an example of class 2 लीवर. Very nice. Is it visible? I mean, is it yeah. Pivot is ground. So this is like the fulcrum. This is like the fulcrum point. Load क्या है? अपना जो weight उठा रहे हैं. This weight which is acting at the central point is load, and the effort is applied by these muscles. So now load lies between the effort and fulcrum. So this is in lifting the weight or raising the weight. In raising the weight, of a body on its toes. This is an example of class 2 lever. Right? So in this case, fulcrum is where? Which point is fulcrum? At toe? Fulcrum is at the end of the toes. And load is the weight of the body. दोनों में खड़े हो गए, एक पे तो खड़े नहीं हो गए. Weight of the body used trying this exercise. And effort is muscular force at the other end. Effort is muscular force at the other end. Right, this is example of class 2 lever in the human body. Class 3 lever. This is clear. Tejasvi, Shrey, Vihan, Jesh. Example of
Yes,
class
sir.
Yes.
in the body.
Yes, sir.
Right. Class 3 liver. Example of class 3 liver in the human body. बेटा अपने लाइफ साइंसेस वाली जो बुक है उसके एक्सरसाइज के क्वेश्चंस की फोटो खींच के लाइफ साइंस वाली बुक है ना आपके पास
लिविंग साइंस सर हाँ है
लिविंग साइंस एक ही बात है यार लाइफ साइंस लिविंग साइंस टची हो जाते हो हाँ लिविंग साइंस यस उसके एक्सरसाइज के क्वेश्चंस को आपकी फोटो क्लिक करके ग्रुप में शेयर कर देना सो दैट वी कैन डिस्कस द क्वेश्चंस फ्रॉम देयर एज वेल for all the chapters. Last year we did 3 different books for the ICSE syllabus and then we did something extra also. थोड़ा broader perspective में broader knowledge में काम करते हैं ठीक है चलो very good हाँ class 3 liver example क्या है class 3 liver example is in raising your forearm or when you take a load in your forearm. Class 3 liver in human body. Right? Yes. This is the थोड़ा से टाइम पास कर रहा हूँ I'm making these notes good for you so that I'll share this. Yes, I hope this is also clear.
क्लियर सर
Okay, very good. So the effort is pivot is the fulcrum, effort is in between, and then is a load. When you are lifting something, then basically you are overcoming the load. Right. Yes, boss. This is the class 3 lever. Effort is in between the fulcrum and load, and in which elbow is where? Sorry, fulcrum is where? Fulcrum is at the elbow joint, right? Effort is obviously applied by these muscular forces. There is no other option in the effort is at the muscular forces and load is जो भी हम लोड उठा रहे हैं the weight on the palm, the load on the palm. Right? This is how all the 3 type of livers are there in the human body. All the 3 livers are present in the human body and right. Fine. So this was a very simple thing, but yes, we tried to And there's example number 2. Draw a diagram to illustrate the action of biceps muscles as a lever. So there is another diagram that's given on page, in your book. This is the upper arm. This is the diagram showing the working. This is your arm. It's an example. So I'm just using that to explain. This is the upper arm, the side one. And this is your load arm on which we are having a load on the palm. This is palm. Load. Fulcrum is this joint. The muscular forces are represented by this spring kind of thing. This is the effort. This is the bicep. This is applying effort. Beta Kabir. Okay, fine. So this is the chapter exercise 1. This is completed. I mean, before the exercise 1, all the theory has been completed. Exercise 3A. So now I would like you to solve the questions of exercise 3A completely. कुछ हम अभी कर सकते हैं या आप होमवर्क में कर लोगे तो बेटर है. I need to go. I have the vaccination appointment. Yes. So these exercise questions, all questions are very easy. Numerical से पहले वाले questions भी आपको करने हैं. Exercise 3A is in homework. Right? एक छोटे से हम कुछ numerical के एक दो questions कर लेते हैं. In next 5 minutes we have. Question number one question says a pair of scissors has its blade. A pair. This is a question from your exercise only. A pair of scissors has a blade 15 centimeter long. So what is this? This is a effort arm or load arm? Mr. Jayesh, this is effort arm or load arm?
Sir, this is load arm.
Load arm.
No,
Right?
yes. Sir.
Load arm is 15 centimeter. Effort arm is, it says the handle is 7.5 centimeter long. The pair of scissors blade length is given as 15 centimeters. Handle is 7.5 centimeter. Find the mechanical advantage. Obviously, it is used as a force multiplier.
Sir, the mechanical advantage is 1 by 1.5.
Right. ऐसे ही कुछ छोटे छोटे क्वेश्चन है बच्चों वाले. You have to finish this exercise. Tomorrow we'll discuss this exercise. Discuss exercise 3A. जो
सर
difficult
टुमारो
होगा.
सर कल टेस्ट नहीं है.
टेस्ट क्लास के टाइम में थोड़ी होगा. क्लास के टाइम में है तो मेरी क्लास में क्यों होगा यार. मैं चेक कर लेता हूँ.
Sir, time क्या है प्लीज बता दो.
12:30.
Sir.
Shashti ma'am will confirm. मैं अभी check कर
सर
लेता हूँ.
सर्कुलर में 2 टाइमिंग दिए हैं, 2 टाइमिंग दिए हैं, एक मॉर्निंग का एक इवनिंग का. तो इस पे कौन सा में करना है?
यार मेरी क्लास मत लो. इवनिंग में टेस्ट कर लो. ठीक है. इवनिंग में टेस्ट कर लेना. I will teach
Sir.
tomorrow to complete this
But-
topic.
तो हमें ये पूरी एक्सरसाइज भी करनी है आज.
एक्सरसाइज भी करनी है।